This is the Earth Science Classroom. This is the Scientific Method, Unit 1 playlist, and this video is looking at accuracy and precision. So the objectives of this video is to establish definitions for both accuracy and precision, to give examples for both and relate them to the scientific method, and also to get the students to think about basically how to think as a scientist, how to transfer your way of thinking and your selection of choices and how you work through problems as a scientist would. So there's some few diagrams and pictures in the front, basically looking at this wood cutting exercise right here, and you've got these various dartboards and archery targets as well, basically signifying both accuracy and precision. And there's a cool saying in like carpentry or any kind of like you know, making things with your hands, is that you measure twice and cut once. That's basically saying that you double check your work. You make sure that your measurement, your sizes of whatever you're working with are correct before you then go and cut your material. Because once it's cut, you can't then add more on, or maybe can't adjust it from there. So you always measure twice, cut once. So accuracy is defined as how close you are to an intended target or a value you're trying to hit. So within an experiment, within the scientific method, in the experiment, you're going to have variables, you're going to have various elements that you have to try and control or analyze or dictate. But the accuracy of your procedures, your handling of the experiment is going to dictate the outcome. It's going to dictate the level of analysis that you can produce on the data set. It's going to look at, the data itself can be controlled or even highlighted through accurate performances or details within the experiment. So it's very important that the scientists would increase their accuracy and get as close as they can to that target or value to improve or develop the experiment to its fullest, therefore giving you the best opportunity to analyze and conclude on what you found in the experiment, so that the method is exercised properly and it's most efficient, most productive. So if I look at a target, say we have a darts game in this picture right here. So the bullseye, right, it's worth 50 points, the bullseye. There we go. So in darts, you have to hit the actual target, the whole thing, but hopefully, well, the most points you can get on a single throw is hitting the bullseye like this arrow has, this dart has, and it's 50 points. And each different area has different point values associated with it. But right here, so you would say that this person who threw the dart is accurate because they hit the exact middle of that target. So the value that was intended, or the target that was the objective of the throw, was performed and hit correctly as it's shown hitting the bullseye. Now, if you take a second dartboard here, and here's my bullseye right there, and I throw the dart and it lands here. So there's my dart. There's my dart. It lands outside of the target. Now, I would say this is inaccurate, that I have missed the target and that is not close to my intended value or target. So obviously I'm not hitting the target, it's not going to be accurate. And the degree of accuracy can fluctuate depending on the value or target that you're trying to hit. In this case, a darts board, you have various values around the dartboard, but the center has the highest value, right? The bullseye. So we can say that this is discrete. You're either yes, you're accurate, or no, you're accurate. You can add a degree of accuracy, but it's pretty much discrete, yes or no. And it's based on a singular attempt. Single attempt, one dart, one arrow, and usually is just a singular measurement. Now, on the flip side, precision is the repeated multiple attempts at a target or a value, and it is the closeness, how close each attempt is to the other. So it is the distribution of the attempts and the relationship between them, like how close they were altogether. So this can relate to accuracy, or could be completely different. For example, right, this diagram right here is showing an arrow and a target. The target, obviously, in the center of the yellow circle is the perfect aim, the most accurate aim on this target. Now you can see that there are multiple arrows that have hit the center of the yellow circle, denoting that all of these are accurate. They all hit the target, and they are all at the highest level degree of accuracy, and it's repeated, and there's 3 arrows. Now these are also precise. And it shows precision because all 3 arrows are in the same area, the same location. They are all close to each other. So what you're seeing here is an accurate and precise aiming from this archery example. However, if I had the same archery target right here, and here would be my objective and target and value right in the center, I could actually shoot my arrows, and they could all be right here. So what I have is I would miss the target, so these all missed. So in terms of accuracy, it wouldn't be counted. They are inaccurate. I have missed the target. However, all of these attempts are all close together, so I can say that this is a precise data set, precise arrow shooting, that I have missed the target, but I have been able to have all my shots, my arrows, go in the same place, so I'm very precise. So this is repeated. So there's a difference when you have accuracy and precision, how they relate together. So to wrap it up, the overview of accuracy and precision are in the top right-hand corner here, and it can use this topic to connect not only the empirical experiments and use of data and how scientists have to be precise and accurate, combined to formulate supporting analysis and conclusions, and to follow the scientific method, the 7 steps. Then link it into how students observe the world, the natural world in earth science, and how they make inferences based on those observations, and how those inferences can affect the outcome and the data. The data sets themselves have to be accurate and precise all the way through to improve the quality of the analysis. And then you can look at the qualitative data sets versus quantitative data sets, and the use of mathematics and stats in quantitative. And I'll see the experiments. Now, I spelled experiments wrong. There we go. Experiments and the variables that would be involved. So the dependent variable, which you're measuring the data, and the various independent variables that you can move and dictate within the experiment. Maybe a control variable as well, control group. So all these can be connected as one to bring about a more scientific view on looking at data in earth science, and using this all the way through our curriculum and our different units when looking at different topics. All right, thanks, guys.